Okay, before I forget it, just as dy dx is another symbol for f prime of x, and we call that Leibniz notation, we need to look and see what Leibniz notation looks like for the second derivative. So if you want the second derivative, you're taking the derivative with respect to x of the first derivative. Okay, the derivative with respect to x of the first derivative. So we would write using Leibniz notation that like this. But this is rather long, so we shorten it to this. I say that because in one of your homework problems in WebAssign, it will use this symbol. And that's the symbol for the second derivative, just in this Leibniz notation. Again, the second derivative is the rate of change of the first derivative, the derivative of the first derivative. Okay, here's an action item. I need for everybody, absolutely everybody, to do this. Email me 2 questions that you are pondering over this entire lesson. You can do it after you finish the lesson, that's fine. But before you do the WebAssign, or after you do the WebAssign, just before the next class period, email me 2 questions that you're pondering. If you're really thinking about this lesson deeply, there's some questions you probably will have. So I look forward to seeing and responding to those questions. Okay, final problem, page 301, section 4.3. Again, we're doing a condensed version of chapter 4, so we're just kind of starting here in 4.3. Number 27, sketch the graph of one function that has each of these properties. And they give us 1, 2, 3, 4, 5 properties. So we don't want 5 graphs. We want one graph that has all of these properties. So I'll let you look at those for a minute, and what I want you to do is over here, I want you to write what each one of these properties, what each one of these 5 properties would mean for the graph. What does it mean if the first derivative evaluated at 3 has the same value as the first derivative evaluated at 2, which has the same value as the first derivative evaluated at 4, and that value is 0? What does that mean? Well, it means that there is a horizontal tangent. In other words, the graph flattens out, the graph becomes horizontal. There's a horizontal tangent line at the points having an x-coordinate of 3, x-coordinate of 2, and x-coordinate of 4. Notice we don't know how high the points are. We don't know f of 3, f of 2, f of 4, but we know there's horizontal tangents there. Okay? What does this mean? F prime of x is greater than 0 if x is greater than 0 or if x is between 2 and 4. What does that tell us about the graph of f? Well, this gives us the intervals over which f is increasing. Remember, the first derivative being positive corresponds with the function increasing. So f increases when x is less than 0 and also when 2 is less than x is less than 4. Those are the intervals of increase. How about the next item? F prime of x is less than 0 if x is between 0 and 2 or bigger than 4. What does that mean? It means f decreases when x is between 0 and 2, and when x is greater than 4. Remember, the first derivative being negative means the function decreases. How about the second derivative being greater than 0 when x is between 1 and 3? What does that tell us? Tells us f is concave up. When x is between 1 and 3. And the second derivative being less than 0 tells us that f is concave down when x is less than 1 or x is greater than 3. Now, I want you to try to produce a graph, because you'll have to do this in homework, okay? It's a different problem. Boy, this would be a good bonus for the test, wouldn't it? Remember, I said that 10-point bonus on test 4 would be something from that we're doing this week in chapter 4. I have to think about what that bonus would be, but I think this would be worthy of a bonus. So think about trying to draw a graph. It's like a puzzle. There are lots of different graphs that are possible, but they've got to all have these properties you've written over here. Think about what that graph would look like. Try to draw that graph, and then we'll show you in the next podcast, Pencast.